So let's take a look. How do we type a matrix in Geogebra? Well, we need to give it a name. I'm going to use capital T, which is traditional for a transformation matrix. And a matrix is basically an array of numbers, and what we do is we use curly brackets around the entire matrix, and then we use another set of curly brackets for each row. So for example, 1, 0 within the first curly bracket, so use the arrow key, comma. The second row, say 0, -1, enter, and here we have our transformation matrix T. Now that's going to do certain things to images, and what we're going to be exploring is what different transformation matrices do to different images. So let's go ahead and load in an image. If we go to edit, we can insert an image from a file. And you could really pick anything you've got saved. I went into the pictures menu, and I'm going to go with the penguins, and it will insert the penguins picture into the Geogebra window. I'm going to right click on that picture and give it a name. And we'll go to rename. I'm just going to give it a capital P. Alright, now down here in the input line, the command we want today is apply matrix. We're going to put the matrix first, which is T, our transformation matrix, comma, and then our image, which is P. And when we hit enter, what Geogebra is going to do is multiply every single point in that penguin image by the matrix T, and the resulting new image is transformed somehow. In this case, it looks like it's been flipped upside down. If we use our move tool, we can grab the original image, and as we move it around, you can see that the transformation is also moving. So it's being computed dynamically. I'm going to go ahead and line that up with the corner on the origin. And so it looks like this particular transformation matrix T is a reflection using the x-axis as the mirror, so that up becomes down, down becomes up. But what if we go back and change that T? So we can come in here and double click on that, and we can just go ahead and edit. And maybe what I want to do this time is 0, 1 for the first row, comma, and we need curly brackets again. Let's do 1, 0 and a curly bracket to match the first one to end it. As we move around our original image, you notice that the transformed image is also moving, and this doesn't seem to be a reflection, or does it? It's not the x-axis, it's not the y-axis. Let's take a look at this. Y equals x. Well, that line, the line y equals x, as the mirror. Yeah, that's exactly what's going on here. All right. Let's change T again and see if we can get it to do something else. Let's change one of those ones to a -1. Same position, but it seems to have flipped around, and as we move, we notice a very different behavior this time. This is a rotation where the penguins have been rotated. As we zoom out, they've been rotated 90 degrees around the origin in a counterclockwise, and counterclockwise is the default for when we do these kind of things. So we can see that Geogebra is a very powerful tool where we could be using any image. We can create this transformation matrix T, and we can apply it to our image, and then by simply editing T, we can examine the effect of different transformation matrices on our image. And we're going to try to classify them as rotations, reflections, dilations, and maybe combinations thereof. So that's where we're headed with this, and that's what we're going to be looking at over the next few lessons.